Here are low and high spin configurations in octahedral complexes with items found in our bags. We use chapsticks as the molecular orbitals and highlighters as the electrons. A metal ion hanging out alone has 5 degenerate d-orbitals, which means they all have the same energy level. When ligands approach a metal, they disrupt the peace and the degeneracy is broken. Crystal field splitting occurs, splitting the orbitals into 3 T2G and 2 EG orbitals. After the field is split, the filling of the orbitals can begin. For a metal with 1 d orbital electron, the electron fills into the lowest energy level molecular orbital. With 2 d electrons, the electrons fill into the lowest energy level MO, but fill into separate orbitals. Everyone wants their personal space. The same pattern is followed for a metal with 3 d electrons. For a metal with 4 d electrons, the electrons can fill in 2 distinct ways. The first, called the low spin configuration, has all the electrons filling into the lowest energy level MOs, pairing up when needed. The second is called the high spin configuration. This method has the electrons trying to get as far apart as possible and have the least amount of pairing. This is the low spin configuration for a metal with 5 d electrons, and this is the high spin configuration. For 6 d electrons, here is the low spin and high spin configuration. And similarly, for 7 d electrons, we have a low spin configuration and high spin configuration. For a metal with 8 d electrons, there is only one ground state possible, no high or low spins. The electrons are stuck where they are. We again only have one ground state for a metal with 9 d orbital electrons. For a metal with all 10 d electrons, all 5 orbitals are filled with 2 electrons, and we have completed all possible d electron configurations.